Alright, Chapter 1 Summary. Before going into Chapter 2, read the following summary of the material. Chapter 1, the summary reinforces what you have already learned. DC and AC current. Direct current is one direction, while alternating current is constantly changing the amplitude of the direction. Advantage and disadvantage of the AC and the direct DC direct current have the disadvantage compared with the alternating current. Direct current, for example, must be generated at the voltage level required by the load. Alternating current, however, can be generated at high level and step down with the consumer and with the U for the transformer through a U for the transformer. Whenever the voltage required by load with the sum of the power of the DC system must be transported low voltage to high current level. The amperage squared over the ohms power loss become the problem in the DC system, since the power of the AC system can be transmitted at a high voltage level or a low current level. The amperage amperage squared of the resistor ohms power loss of the AC system is much less than the DC's system. Voltage waveform. The waveform voltage current with the graphical picture chain with the voltage current value over the period of time. A, the direct voltage rectangular wave, the sawtooth wave, and the sine wave alternating voltage. All electromagnetism, when the compass is played with the vicinity of the current carrying the conductor needle assigns itself the right angle of the conductor of the north pole of the compass indicate the direction of the magnetic field to produce the current. By knowing the direction of the current, you can also use the left-hand rule of the current to determine the direction of the magnetic lines. The force electromagnetic field the clockwise, the compass show the battery, the fixed resistor going from the negative to the positive over the switch of the north pole with clockwise. Then it goes from the counterclockwise when the negative goes through the fixed resistor through the switch, and then through the compass or the plastic board compass needle is still turns counterclockwise from south to north pole. Arrows, generally electrical diagrams, indicate the direction of the current wire with the positive end of the cross-sectional view wire indicate the current flowing through away from you for a while the dot indicate the current is flow towards you. When the two adjacent parallel conductors current in the same direction from the magnetic field of the round with the conductor, each of the other current of the current is in the two conductor field flow of the opposite direction field of the round with the conductors opposite of each other. Heart current flowing in the same direction, current flowing in the opposite direction. Repel. The magnetic field over the coil of which wire wound around the core with the form of the coil, but the magnetic field produced the current flow over the coil combined the combined influence of all of the field around the time it turns to produce the two pole fields similar with a similar bar magnet. When the direction of the current coil is reversed, the polarity of the two pole fields the coil is reversed. The strength of the magnetic field of the coil is dependent upon the number of the terms of wire in the coil, the amount of the current in the coil, the ratio of the coil length of the coil width, and the type of the material in the core. The basic AC generation of the conductor is magnetic field. Either the field of the conductor moves an EMF, the voltage induced the conductor, the effect of the called electromagnetic induction. The loop of the wire rotating the magnetic field produces the voltage constantly changed by the amplitude, the direction of the waveform produced the sine wave of the graphical picture of the alternating current with the AC with one complete revolution is 360 degrees. The conductor produces one cycle of the AC, but the cycle is composed of the two alteration, positive alteration, negative alteration. One cycle of AC is 1 second of the hertz or 1 hertz. One alteration 180 degrees, 3060 with one alteration 0 to in the conductor's cross points. Frequency, the number of cycles per second required, referred to as frequency. AC frequency measured in hertz. Most of the equipment is rated with the frequency as well as the voltage as in current. Period of time required for the complete one cycle of the waveform is called the period of time. Each AC wave is composed of two alteration which occur during the time of the sine wave is called the positive alteration which occur during the sine wave. The negative is called the negative alteration. In each cycle of the sine wave, two alterations are identical inside of the shape of the opposite polarity, but have opposite polarity. Period of sine wave is inversely proportional with the frequency. High frequency voltage. Short period. The mathematical relationship between time and frequency is time over 1 frequency or frequency over 1 over time. Your period amplitude, the positive alteration, negative alteration, 1 second on time axis. Wavelength, the period of sine wave is defined with the time of the case complete. One cycle, the distance of the waveform converges. Period referred to the wavelength. Wavelength is indicated in lambda. Is a Greek symbol. The measure for the point of the given waveform is a sine wave to the corresponding point of the next wave. The alteration of the period of time, positive and negative alterations, wavelength, distance, peak on the peak to value of the maximum value during the one alteration of the sine wave, the peak value, and also the maximum reached during the positive alteration, the maximum value during the negative alteration is called the peak to peak value. Is twice the peak value. So you have a peak value and peak to value that show the instantaneous value of the sine wave, the alternating voltage current value of the voltage current at one particular instant time. There are infinite number of the instantaneous value between 0 and the peak value. Average value. The average value of the sine wave of the voltage current the average of all instantaneous during one alteration. The average value is equal to 0.636 to the peak value of the form is the average voltage, and the average current is the average voltage 0.63 times the average max voltage max. Ampere voltage is 0.63 times the amp max. Remember, the average voltage average and ampere value is for one alternation current. The average value of the complete sine wave is 0. Alright, effective value with the alternating current of the voltage is the value of the alternating current of the voltage produced the same amount of the heat resistive of the component that would be produced in the same component. The direct current of the voltage of the same value. Although the effective value of the same value is equal to 0.707. Effective value of the peak time 707 times the peak value. The effective value is also composed with the root mean squared value. So the terms of the root mean squared value is used to describe the process of determining effective value with a sine wave value using instantaneous voltage of the current value confined with the root mean square value with the current voltage taking the equal space instantaneous value with the sine wave extracting the square root of the average sum of the instantaneous value there with the root mean square value that comes from the formula that affects the maximum value of the voltage. Voltage efficiency is equal to 0.70 times the voltage max. Voltage max is equal to 1.414 times the voltage efficiency. Amp efficiency is 0.7 times the voltage max. Amp voltage max is equal to 0.14 times the voltage efficiency. Show that the percent of the 0.0707 is the effectiveness, so 63.6% the average peak to peak. In the peak. So the sine wave in phase, the two sine waves are exactly stepping each other. They are said to be in phase. To be in phase, the sine waves must go through the minimum and maximum point at the same time in the same direction. So you have the voltage wave and the current wave at the same time. They go through the x-axis at the same degree in the same direction at the same time. Or sine waves out of phase. The two sine waves go through the minimum and maximum points at the different times. The phase difference between them. The two waves are said to be out of the phase with each other. To describe the phase, the difference, the term lead lag of the u of the wave and the reach of the minimum and maximum value first led to the other wave. The term lag is used to describe the wave that reaches the minimum or maximum value at some time after the first wave does. When the sine wave described leading and lagging difference for the degree that is usually stated for the example of the wave E1 leads the wave E2 by 90 degrees, and wave E2 lags E1 by 90 degrees. Remember that two sine waves that can differ the number of the degrees of 0 to 362 sine waves that are different with them. Two sine waves that differ 0 to 360 are considered to be in phase. Two sine waves that are opposite but the polarity differ with 180 degrees are said to be out of phase, even though they are go through the minimum and maximum points at the same time period. Show the E1 and E2 90 degrees, time 1, time 2. Ohm's law and AC circuit. All DC rules and laws apply with the AC circuit. That contains only resistance. The important point, remember, is do not mix AC values. So all DC rules laws apply to AC circuits that contains only resistance. So do not mix the AC values. Ohm's law value of the AC circuits are given as the ampere is equal to voltage over the ohms. Amp efficiency is equal to voltage efficiency over ohms. Average is equal to voltage average over ohms, and amp peak to peak is equal to voltage peak to peak over ohms. So as long as ohms is in the equation, then it applies. And these are the answers, and we'll move on to section 2, inductancy.